All right, so the line y equals x minus 2 meets this cubic so we're given one of the roots because we know it meets at point F where x equals 2. So 2 has to be one of the roots. Of course, when I set them to equal each other, I get x minus 2 there. So I get x cubed minus 5x squared plus 5x plus 2 equals 0. And I know one of these roots is 2. So if I sub 2 in there, I'm going to get 0. So one of the roots is 2. But of course, it's cubic. So I've got two other roots, A and at B, where x is alpha and beta. So it's got to satisfy this equation. All those roots have to satisfy this equation. So if I do the sum of roots, because I want alpha plus beta, so let's say we've got roots alpha, beta, and gamma's 2, then I know the sum of roots is equal to negative b on a, which is 5. So I know that alpha plus beta equals, take away 2, is 3. All right, now if that is the case, they want me to find alpha plus beta and hence find the coordinates of the midpoint of A, B. So if I add these roots up and they equal 3, then if I average them, I will find the midpoint. So of AB, so midpoint AB equals 3 on 2 something. Now, of course, put it in the easy equation. If I put it in y equals 3 on 2, take away 2, which is the same as 4 on 2, I get negative 1 on 2. So that's the midpoint, so negative a half. Oh, okay, so 3 on 2, negative a half, 3 on 2, negative a half. So I've drawn a picture, but of course it's not to scale because it should be over here. 3 on 2, negative a half should be over here, that it's meeting, is the midpoint of AB, so don't look at my picture. All right, so if I've got two roots, let's say A and B, and then the midpoint of them is at x equals 3 on 2, y equals negative a half. Okay, now what am I interested in here? So show that alpha beta, so let's use the product of roots, so 2 alpha beta. So negative b, c, negative d, so negative 2. So we'll get alpha beta equals negative 1, which is what we want. So that's just using negative d on a. So negative b on a is the sum, d on a is the sum of doubles, and then negative c on a, negative d on a, that will give us the sum of triples, which is 2 alpha beta. All right, so we found alpha beta equals negative 1, and then we're going to use the fact that alpha minus beta squared is alpha plus beta all squared, and we know alpha plus beta is 3. So we've got 3 squared minus 4 lots of alpha betas, which we just found. So we've actually got 9 plus 4, which is 13. Now, we know that if we find the positive square root, so we're just finding the positive square root of that, we get root 13. So the distance between, the distance between, same thing here, alpha and beta is root 13. So root 13, whoops. And remember, alpha and beta are the x values, so that's the horizontal distance, is root 13. Okay, hence find the length of AB. All right. Well, we know that alpha and beta lie on the line, both A and B lie on that line, y equals x minus 2, where the gradient is 1. So if I go across root 13, I'm also going up root 13 there. So if I want the distance between these two, alpha A and B, the points are A and B, I can use Pythag. So AB, distance AB, I really should say, or interval AB is the square root of root 13 squared plus root 13 squared. So we get root 26 units.